Unit 4.9 Quadratic System. The class objectives of this unit is to solve and graph system of linear and quadratic equations as well as quadratic inequalities. Two terms that you have to pay attention to. First, system. It means more than one equation or inequalities. Next, to solve. When you ask to solve a system, it means you have to find solutions that will make all the equations or inequalities in the system become true. When you are asked to look for the solutions of a system, you are basically looking at the intersections of the equations inside the system. So first, let's take a look at the linear quadratic system. As the name implies, in the system we have a line, which is a linear equation, and quadratic, which is a parabola. So in this kind of system, you have at least one quadratic equation and one linear equation. So in this case, when we have only one quadratic equation and one linear equation, in your graphs, you're going to have only one, of course, one parabola and one line. If you have more than one quadratic equation in the system, you will have more than just one parabola. If you have more than one linear equation in your system, you're going to have two lines. So this is the really basic form of a linear quadratic system in which you have only one quadratic equation and one linear equation. So in this basic linear quadratic system, you have only three scenarios. The first one, you have two solutions because as you can see, there are two intersection points. So these two are the solutions for the system. The second scenario is that you can only have one solution right here because this is the intersection point between the parabola, the quadratic function, the quadratic equation, and the linear equations right here. The last scenario, you have no solution because the quadratic equation doesn't intersect with the linear equation. Now, let's take a look at an example of how do we solve a linear quadratic system by graphing. So here's the system. So all you need to do, you can either graph it manually or you can use your graphing calculator to do it. So in this case, we use the graphing calculator to do it. We sort of plug in the equation, the quadratic equation for the parabola, the quadratic function here, and then we plot the linear equations. So here's the intersection points right here, and these two are the solutions of the system. So we can always check by plugging these 2 points back to the equations. So take a look. Since the solution says x is equal to 0 and 6, which is this point, we plug in the value of x0 right here and the y value of 6 right here. We put a question mark here because we want to check if they are really equal to each other. So after all this arithmetic, we find out they are true for both equations in the system. So this is the skill of using graphing to solve a linear quadratic system. Other than graphing, we can also solve linear quadratic system by substitution. Here's an example. So this is the quadratic equation because we have the second power, and for linear we have only first power. So the substitution is to substitute y right here. Let me create the screen. So we substitute y, which is equal to x plus 3 to this y. So that's why you have the first equation right here. So once we have this equation set up, we can change it to a standard form like this. what they did is they just do the inverse. So what they do on the right hand side, they do the same thing on the left hand side. So if you simplify the whole thing, it's equal to x squared plus 2x minus 3 equals 0. The next things, of course, they try to do the factoring by making use of the strategies of the sum of factors. Now they have x minus 1 times x plus 3. So then they make use of the zero product properties. And make it x minus 1 equal to 0 or x plus 3 equal to 0. That's why they end up getting x equal to 1 or x equal to negative 3. Once they know x is equal to 1 or x equal to negative 3, they can basically substitute the value of x equal to 1 or x equal to negative 3 back to this equation to solve for y. We can always use the first one, the quadratic one, but it's more like, difficult because we involve square and everything. So it's easier for you to solve for y, just plug in back to the linear function instead. So y equal to x plus 3. So for the first case, when x equal to 1, y equal to 4. In the second case, when x is negative 3, this is x plus 3, so y equal to 0. So the solutions are the intersection points between the quadratic equation and the linear functions, which are 1, 4, and negative 3, and 0. Now let's take a look at how do we solve a quadratic system of equations. So when you take a look at the system, this time both of them are quadratic equations. You can tell from the power right here. So we are dealing with two quadratic equations here. So the first method we're going to use is substitution. Basically, it's the same as what we just did, but this time instead of dealing with a linear equation, we are dealing with two quadratic equations. So they set it up like this, because both of them equal to y. These two things are equal to y, so we put them together as an equation, just like this. Once we have this equation, we can change the whole thing into standard form by doing the inverse of this side, which is minus x squared minus 7x minus 12. So since it's an equation, what we do on the right, we have to do the same thing on the left. So we're going to do the same thing right here. So that ends up to 0, and this one, if you simplify that, you're going to have minus 2x squared minus 8x. The next step, we do factoring by using the greatest common factor. In this case, it is negative 2x. So by doing that, we change this into factor form, and then we make use of the zero product property, and then we can set up negative 2x equal to 0 or x plus 4 equal to 0. So if we solve it, so x is going to be equal to 0 or x equal to negative 4, which we have it here. And then once we know what x's are, then we can substitute the x values back into the equation right here to solve for y. So since x equal to 0 right here, so put it right here, then we solve for y. So after you find y, the solutions, as we said earlier, are the intersection points. So they are 0, 12 and negative 4, 0. I just showed you how to use substitution to solve a quadratic system of equations algebraically. Now I'm going to show you another way to do it, to solve the system by using the calculator. So all you need to do is to use your graphing calculator by input your equations right here. Look, so this is a system of two quadratic equations right here. So once you enter this one correctly, Then we use the intersect function in your calculator to find the points of intersections. So these are the intersection points, which are the solutions to the system of these quadratic equations. The last part of this unit is to solve a quadratic system of inequalities. Here's the example. So when we talk about inequality, we are talking about this sign. So it could be either greater than, less than, greater than or equal, or less than and equal. So in this case, first we have to draw the first inequality. In this case, this is the one. So this curve represents y equal to negative x squared minus 9x minus 2. The reason we use a dotted line or dashed line is because this is less than. There's no equal sign here. If there's an equal sign, we're going to use the solid line. Once we have this boundary, then we can use a testing point to test which part of the plane we're going to take. So say right now, because it crossed 0, 0, so we're not going to use 0, 0 to do the testing point. How about we just pick this point as a testing point? So this one's going to be negative 3, 0 as a testing point. So we plug this in to see if it's true. So y is it less than negative, this time x is negative 3 whole square minus 9 times negative 3 minus 2. So we want to check if it's really greater than 0, because y is 0 right here. So let's take a look. 0, and then I'm still question mark, I don't know. So negative 9 plus 27 minus 2. So I got 0. Is it less than 16? Yes, it is true. So since it's true, we're gonna take this part. So I shaded it with the pink line so you can see it. And then we do the same thing for the second inequality, which is this one. Alright, we're doing the same thing. We draw the graph of y equal to, this is y equal to x squared minus 2. This is the boundary. We use dashed line because there's no equal sign here. And then we do the same thing. We use, this time we can use the 0, 0 point to test it, to find out which part of the plane, the coordinate plane, we're going to take. So after we do the same thing, we know this part is the one we're going to take. And if we put two things together, if you move this whole thing here, so we have, say this time I'll use horizontal line for the solution for the first inequality. So if you draw it properly, the intersection is this part. Okay, I try to highlight it for you. And this is the solution for this system of inequalities.